Lesson 11.1, Writing and Graphing Inequalities. So your goal is to understand how to represent situations that involve not just a single answer, but a range of answers. So let's talk about why we need inequalities. Take a look at the next slide. All right, so what we're talking about is basically the difference between equations versus inequalities. So take a look at these two problems here. They sound almost the same, but not quite. Here, the band raised $500. Here, the band raised over $500. And so the difference between equations versus inequalities is that this top one we would symbolize with an equation because it only has one solution. In other words, we'd write it something like this, that let's say B, what the band raised, is equal to exactly $500. One answer and one answer only. But for something like this, we're now representing a whole range of answers, what we call a solution set. And so what we have to do is we have to use other symbols to represent this, where B isn't just equal to one thing, it's representative of a whole range of possible answers. And so what we need is symbols that help us describe that, which is where we get inequalities. So here's our inequality symbols. What we have here is less than, or fewer than, the greater than or more than symbol. And then over here, this less than symbol again, but with this little line right here. Well, this little line is basically half of an equal sign. It's saying that our answer can be either less than or equal to this amount. And of course in English there's always more than one way to say it, so these are other ways to say the same thing that still relate to this symbol. And then of course our last one, greater than or equal to. So these are the symbols that we're going to use in this chapter. We're going to talk about not just single answers but ranges of answers, solution sets. Alright, so this is the type of problem that we might look at. So let's say I need to represent this problem. You must be over 12 years of age to enter. So what I would do is something like this one. I would say A is my age. Oops. Oops, that's wrong. Scratch. Alright, so let's take a look at this situation. You must be over 12 years of age to enter. So there's not just one age that can enter. There's a whole range of answers I could get here. So to do this, we'd write an inequality. And that inequality would look something like this. If A is the age, then A, as long as it's bigger than or over 12 years of age, they can enter. Now, once you get your inequality, people will ask different questions. Well then, can a 15-year-old go in? In other words, is 15 a solution to this problem? Is it one of those solutions in the range? Well, it's a simple matter of just plugging it in. Is 15 greater than 12? Well, yes it is. And so a 15-year-old could go in. Now, a different way to ask that, maybe for a different age, it might ask it this way. This is the more mathematical way to ask it. Is A equals 10 a solution? In other words, this is basically saying the same thing as this one. It's asking, can a 10-year-old go in? Well, it would be the same thing. You plug in 10 for A, and is 10 greater than 12? No, it's not. So no, a 10-year-old could not go in. Now, here's where we have to be careful. What about this question? Can a 12-year-old go in? Now here we have to be very careful about the wording and the inequality itself. It said you must be over 12 years of age to enter. So if I plug in this 12 for A, I get this statement, 12 greater than 12. Well, is that a true statement? Can a number be greater than itself? Well, no. And so here's where we really have to be careful, the difference between over 12 or 12 and up, it's very important that we pay attention to the wording. And that's where we get into a little bit of trouble with how do we represent that? How do we represent that in this case that 12-year-old person can't go in, but somebody slightly over 12 years of age could go in? All right, so where do we get these examples? All right, so now that we've seen those two examples, let's take a look at these. You can ride if you are at least 4 feet tall. All right, so what I like to think about is I like to think about 3 cases. Can you ride this ride if you are shorter than 4 feet? No. Can you ride this ride if you are taller than 4 feet? Yes. So we're going to have this whole section shaded with an arrow. Now, what about 4 itself? And here's where these last 2 examples come into play. At least 4 feet tall. So is a 4-foot person at least 4 feet tall? Yes. So we would include the 4-foot person by putting a closed dot. So the 4-foot person can go, and anybody taller than 4 feet. And as far as an inequality, we write it as, let's call it H for height. So the height, you could either be greater than 4 feet or equal to 4 feet, and that would allow you to ride this ride. All right, now look at almost the exact same problem. You can ride if you're over 4 feet tall. So ask yourself the same 3 questions again. If you're 4 feet tall, or if 4 foot height is here on the number line, I should say, if you are under 4 feet, can you ride? No. If you are over 4 feet, can you ride? Yes. All right, but then we get this part. You must be over 4 feet tall. So that, can that exact 4-foot person ride? No. So the way to differentiate it between this situation and this one is here we use an open dot. All right, that way we can tell the difference between whether we're including 4 itself as one of our answers or not including 4, and we're starting at, this would be like 4.000000001. Okay, just past 4. All right, and so that's one of the big things with graphing inequalities, is that an open circle represents a solution set that starts at that number but doesn't include that number. All right, so in other words, right here, the number is 12. And let's put a few more numbers in. I usually like to go at least 2 numbers to the left and 2 numbers to the right of the key number, which in this case is 12. And so I want to show all the numbers that are less than 12, but not 12 itself. In other words, my graph needs to include 11.99998, but not include 12. So I need to show that I'm counting all these numbers over here, but not 12 itself. I need to stop at 12, but not count 12. So what I'll do is I'll put an open dot saying that 12 is not included. So the very first number would be 11.99998, something like that. And of course, we don't shade it in, it actually becomes an arrow like this. Okay, as opposed to this one, we use a closed circle if the solution set starts and includes that number. So here, M is all numbers less than and, or, I shouldn't say and, less than or equal to 12. So 12 itself can be an answer. So I want to start at 12, but I also want to include 12. So I'm going to put a closed dot, shade it in, and M can be anything less than that. So again, it's a subtle difference, but it's an important one. All right, so try these out and then see if your graph looks like mine. And in fact, if you want to pause the video for a sec, you can. All right, so here's what this first one would look like. N is all numbers less than or equal to 12. That's silly, I just did that. All right, so let's wrap up with these 2 sample problems. Graph the following inequalities. So try to graph these 2 in your notes, and if you want to pause the video for a sec, go ahead. All right, so here's how my graph would look. N is all numbers less than or equal to 8. So I start here 8, and then I label a couple numbers above it and a couple numbers below it. And then I ask myself, well, can I include 8 in this? Yes, N is equal to 8. So close dot, and N is also anything less than 8. So an arrow left. So N is less than 8 or equal to 8. So the arrow and the dot. Okay, as opposed to this one, negative 3. And don't forget, on the negative side of the number line, the numbers kind of go quote-unquote backwards. So it should look like this. Alright, so I want my graph to start at negative 3, but do I include negative 3 in the graph? No, there's no equal sign here. X is not equal to negative 3, which means I'm going to start at negative 3 but not include it by putting an open dot. But it is everything less than negative 3. So I'm going to go arrow to the side less than negative 3. Alright, so that's a little bit about writing and graphing inequalities.